please have the honor to please call upon stage Mr. Philipp Wunderlich, Battery Technology Lead Industry X, who will be delivering his deep insights on digital transformation in the battery industry. Over to you, Mr. Philipp.
Thank you very much for this kind and very energetic introduction. I hope I can keep up the spirit and take the next 15 minutes to guide you through this talk. As you can see, it will be about digitalization in the battery industry. It's a topic we've seen in particular being a niche topic in the US and Europe at the moment, but it keeps growing, it keeps gaining relevance. And I think particularly in India, the IT topics could be quite interesting because you're about to set up an industry, you have a skilled workforce, and these topics might be something you may want to look into. Generally, the battery ecosystem, like you've probably heard it from many other talks, and if you get a feeling on the battery show here, you will figure it's moving fast. It's still a bit of a gold rush that is happening. There's a lot of stakeholders involved from different industries, a variety of people from chemical business, from electrochemistry, mechanical, electrical topics. And that means you have to bring together this ecosystem, forge it, and set it up the right way. And the key message of this talk, to give it a head, is take the digital tools that are available today, use them, build this industry efficiently and with the state-of-the-art solutions that are out there, and then basically build it better than, for example, the leading market leaders from China, Korea did. Take this as a chance to innovate. I want to present a couple of use cases in the next couple of minutes, basically walking you through the value chain of the batteries, not just focusing on, for example, the cell manufacturing, but giving you a broader idea of where do we need digital and data, where can it make an impact on improving the battery value chain players' operations, business models, and making the batteries a better product. For example, a topic that is commonly discussed across the entire value chain in Europe, also North America, is the battery passport, a digital product passport for each lithium-ion battery out there. Stuff like life cycle assessment, where you need to rely on a good source of information, very much driven by directives and ESG compliance, is going to be important. And then if you go to the upstream part of the value chain, so from the mining to the refining of the materials to the chem production, you will find a lot of need for traceability, tracking materials through the whole process. And also we looked into, do you need material informatics to, for example, find the new battery chemistry that could be potentially disrupting the market soon. Very interesting is for sure the midstream, the battery manufacturing. So if you go into cell production, battery module and system assembly, you're looking into smart manufacturing solution, digital engineering, getting the benefits out of these use cases, and also looking at digital twin options to kind of give you competitive advantages for your products. And lastly, this will be the third segment of this talk, in the downstream where you apply the batteries in EVs and energy storage, using systems to make it a smart connected product, giving you access to battery and product life cycle data, and then using it for new business models. Could also be tuning some of the business we're doing here. First of all, the battery passport, I will just quickly run through it. It's more or less a directive that is coming in Europe. The battery directive has been in place for a while. It's going to be mandatory requirements for everyone in the ecosystem who is an economic operator of a battery. And the idea here also was to set a global standard for due diligence, for transparency, for example, and using a digital product passport to bring together the different stakeholders in the ecosystem. Because if you pass on the battery from an automotive OEM to the end user, ultimately to a recycler, everyone wants to know what is inside the battery, is it still valuable, what are the materials in there, and those type of data sets will be made available for sometimes the public, selected economic operators like second life manufacturers or recyclers, and also the OEMs are then compliant by basically delivering the set of info. Lots of technical solutions are becoming available, that's the good news. In the last couple of years there was a bit of uncertainty how to tackle this. But nowadays we see a lot of IT solutions for the battery passport. It's linked to traceability, but it's not the same. So here the idea is that you have a platform where you can have, for example, a QR code on your battery. You access it, and then you basically see all the data sets that is required by the policymakers. Traceability is related to it. That means you want to be able to track and trace the material flow or the battery flow through your market. because given the complexity of the ecosystem, it will give you plenty of benefits, especially because you want to know where is the lithium coming from, the nickel, the cobalt. Has it been ethically sourced? Is it low carbon material, or was it coming out of a high energy production? And solutions like this, especially for the upstream, are available. And then in the production itself, where you bring together, let's say, 20 components of the battery cell, merge them into this very complex electrochemical device. There is a lot of gigafactory solutions for the shop floor that allow you to track the materials through the powder handling to the finally aged and formatted cell. And then, of course, in the vehicle, like fleet data management options will be important. You want to know where is the battery? Is it still operating in a vehicle in India? Did the battery somehow leave the country? Because ultimately you need to recycle it, you need to shred it, get the black mass out of it, recover the value of the battery, and just knowing what's inside and where the battery is essential for this business model also to smoothly function and also increase your profitability in this case. And then I think this is definitely a hot topic of the last years in the Western world. It is coming to India, I think, now, and in the next years you see more demand for this, because the question is, how smart are the gigafactories? If we're setting up a modern lithium-ion or sodium-ion cell production plant today, what type of solutions do you need to implement it? And there's plenty. So there's a lot of buzzwords on this slide, but every one of them has a technical substance to it. And the key message here is you need to consider both your shop floor technology, like the coating machines, the car slitting machines, the formation equipment, but you also need to directly plan with the IT systems, which means you need good set of digital tools from the shop floor, from your sensors to your enterprise, linking all of this together to make it an efficient and connected production. This is our thinking of if you set up a plant nowadays, a fresh one, like 5 cases that you should implement or be at least ready to it. The first one is actually having a functional IT and OT setup, so for informational operational technology, which means you need to have solutions like an MES, an ERP, lots of these shop floor solutions that basically orchestrate your manufacturing, that a high throughput facility like a gigafactory wouldn't work. The catch here is that the integration of those usually requires a lot of effort. There's a lot of troubleshooting required in cases, and it's often underestimated how much it takes to actually make these software solutions run. The second is a balanced automation level, of course, heavily depending on the labor cost of the country where you set up the factory, but also given the high precision and speed requirements, for example, in stacking or just moving the cells, human operators cannot handle the mass flow in a gigafactory. So having automation is crucial, but on the other hand, over automation, having too much solutions will also give you problems, because then you can't flexibly react to the many problems that could happen on the shop floor. So this needs to be balanced. The third is an intelligent data management, and this is something often not really thought through, but what you want to have is basically an idea, what type of production data do we need, which one don't we need, because if you just keep storing everything without a plan, saying like, oh, we will just save it for 10 years on a server in the factory, maybe we need it, that can quickly turn into a cost trap. And especially the CIOs and the IT people in the factories are very keen on streamlining this and having a strategy and a clear way forward on their data. The next one is the traceability. As mentioned before, you want to be able to track your batteries and the production flow. Let's say in 10 years, your vehicle is facing recalls, and then the blame game will start. Whose fault was it? And then the cell maker needs to be able, with its quality management system, to show we can trace it back to a certain event on the shop floor, or we can say this was not the cause what caused a battery fire or a thermal runaway, for example. And lastly, the digital twin, because as far as I know, I haven't seen any real digital twin out there yet. It's merely digital models, digital shadows, but that's why we say you need to be ready for a digital twin, because for a lithium-ion battery being a complex physical electrochemical device, you also need appropriate models who can actually handle this complexity. And bringing together all of this, the many components, the changing chemistries over the time, this is where digital twin is really a good playground to experiment with, but something that yet needs to be proven. The next part is looking at the product side. So the batteries are leaving the factories, they're entering the market in either energy storage or in EV applications. And then it's quite easy to turn every battery into an IoT device. With a couple of sensors, with a battery management system, it can be a wireless one. You can basically connect your battery, make an internet of batteries out of this. And considering that your battery is a very valuable asset, in a vehicle can be thousands of dollars of value in materials, you want to manage it properly. And especially in energy storage, where you invest in an asset that may have only one purpose, like peak shaving in your grid, you want to consider like revenue stacking to get access to new functions of this storage, control it intelligently, and maximize what you can get out of this asset. And in order to do so, you first need to be aware what is happening with the storage, get that information out, and especially the lifetime predictions for battery storage is something where digital models can help a lot. The problem is that battery technology keeps innovating. Like new iPhones, every 1-2 years you get a new chemistry on the market. Then you again need a new model, and you need to understand the aging of that system. And then extrapolating the remaining lifetime of the battery can be quite hard. Because for sure that you have a lot of non-linearities in the battery behavior, and hence you need also good models that can handle this. But overall, batteries, especially the big ones, they will be kind of connected to the energy management systems or the fleet vehicle management. And if you're setting up a new business with batteries, maybe think about it like, could you get value out of the data of the fleets that you will have on the roads if you're in control of these data in the first place? Because that's the last point, looking at new business models enabled by data. If you look at the value chain here depicted from like the sourcing of the battery materials to distributing them, having them on the roads or in storage, and then recycling them, you have different, let's say, subsets of business models you can tune based on the availability of the knowledge on your batteries. For example, battery swapping is quite interesting, because if you as the OEM offer a battery swapping solution and you stay in control of the batteries, you keep controlling the loop, you can also definitely stay in control of the data of the battery, and then experiment with a, let's say, risky technology like solid state, be aware how it's aging, and then pull it out of the market because your data indicate, hey, this battery is close to its knee point and limit. But also, like for the recyclers, it will be quite important to know if they get a black mass, what's the actual material content? Is it contaminated with electrolyte that has little or no value? Is there a lot of graphite in there, or just precious heavy metals like nickel or cobalt? So here, data will also make your interconnection to the other stakeholders much, much easier. And lastly, cool business models like sharing platforms, bidirectional charging and vehicle-to-grid are coming. It's often driven by regulations and what the different countries look at it, especially from the grid perspective. But also here, you need to be able to control your battery, get an idea of how the data work, and then leverage this. Last but not least, just to kind of conclude on this whole digitalization topic, you need data. And that's something that I would like to emphasize early on, because if you're setting up something new, think about how you set it up, because if you're doing this too late without a clear strategy, you may get the wrong type of data, you may have a very chaotic approach to it, and you may get just data obesity instead of data richness. You just collect a lot, but you can't get really information out of the data you store. So if you want to kind of succeed in this field, think about it, because ultimately data will cost work and money if you're dealing with them. And this can also be saved if you have a strategy beforehand. And one thing just would like to invite to you, especially if you're on the cell manufacturing or battery manufacturing side, we're currently trying to quantify how digital tools can actually make an impact on cell production by launching a study with a research institute in Germany. So if you want to participate in this study, we want to quantify, if you get a solution actually implemented, how much cheaper can it make a battery cell? Could this be really turned into a competitive advantage? And we're still looking for experts contributing to this. And by this, I'd like to conclude. Here for questions. An honor to be here, and looking forward for the future.
Thank you so much, Mr. Wunderlich, for sharing such a detailed perspective of the presentation. May I please take the honor to share a token of appreciation to Mr. Wunderlich on behalf of Informa Markets India. All right, so we have one question.
Hear me? Yeah, thanks for the presentation. One question on the, is there any standardization planned on this?
Yeah, standardization, it's a very important topic. I think the speaker after the next one will also connect to it, because we're still missing some standards. Like on the shop floor, you will find some interface standards like OPC UA coming, but generally the way we process data along the value chain is missing standards. Between the different factories where we have batteries, we're missing some standards. There's a lot of work to be done still.
Especially the passport, right? It's very interesting.
Yeah.
But then that passport also, you have plans to standardize it globally?
Yeah.
So that everyone follows and everyone understands the protocol, right?
Yeah. The battery passport, for example, the Global Battery Alliance has the ambition and also a bit of lobbying power to make it happen, setting a global standard to it. But ultimately, it's a minimum, let's say, tool, the battery passport, you can build a digital twin out of in the future. So you will, of course, have a minimum set of information. But everything you do on top, this could be a business advantage coming there. So that's why the standards will be the first step. And then tuning it for business value will be the second.
Next 5 years, I can expect something will happen?
Yeah, the battery passport, it will be mandatory in a couple of years. So it's coming for sure. And this will be just a simple digital product passport, maybe even with a link to a PDF. Not a dynamic document. You can even use a bit of blockchain technology to save information. But beyond that, that's going to be interesting.
Yeah, it's good actually, exciting.
Thank you so much. May I please extend a token of appreciation to Mr. Wunderlich on behalf of Informa Markets India.
Thank you so much. Nice.